Hello, AES. Greetings from Minneapolis, Minnesota, where we are in the process of getting our second mid-fall snow in as many days. I'm very disappointed we can't all be together in New York, and I hope that wherever you find yourself today, it's safe, warm, happy, and has slightly less snow than we have here. My name is Ethan Wetzell. I work by day for Bosch Communication Systems in the Platform Technology Group. But I'm speaking to you today as the marketing chair of the OCA Alliance. One of my responsibilities in my position is to work with a number of different trade associations and standards groups on core technologies and standards that can be used throughout the industry. So I always like to be clear about which hat I'm wearing when I give presentations like this. So I am speaking on behalf of the OCA Alliance and the AES70 standard. What we're going to be talking about today is how AES70, one of the newest standards coming out from the AES that focuses on media system and device control, is really opening up some very interesting and revolutionary possibilities and technologies for being able to interconnect, integrate, and control devices together. So we're going to take some time today to walk through how all of this can actually come to play in the real world and some of the things it can do for you that maybe you couldn't do yesterday. So as we go through the presentation, we're going to hop across a couple of different things. I like to begin sessions like this with a quick overview of what a media network is. What are we really trying to do, and what are all of the bits and bobs that go together to make up a real media networking solution? Then we'll have a bit of a discussion on the different kinds of control that are out there and how many different tangents and many different parts of a system can actually be touched on and influenced by control. We'll then shift to talk a little bit more specifically about AES70. We'll talk about some use cases and then move into looking a little bit more in detail at some of the objects and a bit more of the elements of the standard itself. Lastly, we'll wrap up the session talking a bit about where AES70 is today, what kind of products are out there on the market, what are some resources that are available, and what's the future of the standard as it makes its way into the industry. So let's begin at the beginning with a media network. This has really been the buzz and the talk of the town, so to speak, for a number of years. And I'm sure most people out there in the audience are familiar with or have used technologies such as Dante or AVB Milan, Ravenna, or any number of others, where we're taking content, putting it onto a network, and shooting it out from one device to another. That fundamentally is building up what's referred to as a media network, but it's a much more complex structure and architecture than just moving the audio around. Fundamentally, we've got two core needs inside of a media network. Number one, of course, we need to move around our content. So I need to take my audio or my video that's originating in device A, and I need to move that around to different places, device B through Z, as it were. But alongside of that, I also need to have system functions. I need to be able to control elements of the system and interoperate and interact with different parameters and different elements of the system to make all of this work. One of the things we like to say when we talk about things like AES70 system control is it's all well and good to be able to move your content around the network, but what are you going to do when it gets there? And perhaps maybe a little bit more on the nose, how are you actually going to set that up in the first place? You need to have this system control element to be able to talk to your devices and interact with them to set up these configurations for the devices to be able to work together. So fundamentally, we've got our program transport and we've got our system control. Those are really sort of the two cores of a media network. But those functions are supported by a couple of other things that go alongside of them. So in order to keep everything properly synchronized and timed up, we need to have time services. And these fulfill a number of different roles on the network as far as ensuring synchronization and sample accurate playback and a number of other time sensitive functions that exist on the network. You'll see things like 1588 being used as a time service, for example, and this is fairly common across a lot of different technologies. Time, of course, has an impact and has interaction with both the transport and the control side. So this sort of spans across the two elements of the system itself. The other thing that we need to have inside of a network is what's referred to as discovery. So when I have a device and when I plug that device in to the network, that device needs to tell everybody else a few things about it. First off, we need to know it's there. We need to know that something new has been connected. And then we need to figure out what kind of device is it? What's it called? And what is it actually capable of? So what are some of its functionalities? And in the case of control standards, or even setting up transports, we need to know what are some of the different parameters and objects that exist within that device. So a really good example of this is if you're working with Dante devices and you plug a new device in, you open up Dante controller and it's going to show you, aha, new device has been detected. This is the name. This is how many audio channels it's capable of receiving and transmitting. That's an example of discovery and enumerating the different parameters inside of the device. So fundamentally, we've got these two core components, program transport and system control, and those are supplemented by time services and by discovery services as well to tie everything together. So what we're really going to focus on today is going to be some of these control elements and how these actually work inside of a media network and some of the other things that you can do with it. So to begin, I think it's important to recognize that the word control actually is a very loaded word and can cover a lot of ground inside of a system or inside of a media network when we're connecting all of these different kinds of devices together and trying to do different things. So the way a lot of people think about this initially is control is referred to as something that I'm going to interact with parameters. I'm going to mute channels. I'm going to adjust gain controls or tweak EQ filters. It's a very interactive way of adjusting elements of the device itself, parameters of an object or a function of the device, something that I'm actually going to touch. But control actually goes well beyond that and can get into a number of other things. It can also refer to monitoring. And this sounds fairly obvious, but we're getting feedback from our devices in a lot of different ways. A very apparent way is to look at things like LEDs or VU meters that are interacting with and responding to audio or content that's going on inside of a device. But there's a number of other things that we may be looking at. For example, we may be looking at the status of a device, its power state. Is it active? Is it in standby? Is it in low power mode? We may be looking at health conditions. Is the device in a fault state? Is the device actually transmitting and outputting something like a heartbeat monitor so we can keep an eye on constant connectivity and making sure that the device is actually there and okay? So these are kinds of parameters that we don't necessarily directly interact with, but are really, really important to a number of different kinds of systems to make sure that they're operating as they should and allow them to really have the functionality that they need on a system. A third type of control that we could be talking about, going back to the earlier example of using Dante controller, is my connection management. So when I put my devices together, I need ways that I can actually nail up and tear down the audio connections between those devices. So I need to establish transmission lines. I need to set up the parameters for how that device is going to transmit. And likewise, I need to do something to the receive side as well. So being able to manage, control, configure, and actually set up all of these different types of audio connections inside of a system is another critical control function. And of course, there's more. We could be looking at things like automation parameters or scheduled parameters or functions that are based on rules or logic engines that could be existing within a device. So if a certain type of control is detected or received. If a device goes into a certain kind of state, then something else will happen. A control message goes out, either internally to the system to recall a certain state, or maybe to alert something else on the system as to what's going on. So control can cover any or all of these functions inside of a system or inside of a media network. And this is one of the reasons that control becomes actually a very complicated thing to talk about and a very complicated thing to integrate into a system or a piece of hardware. All of these different things need to be accounted for and considered. So it becomes a very, very complex landscape of figuring out how the designer is going to implement all of these things and how the installer or the operator is actually going to take advantage of them and make them work. Compounding all of this complexity, we've actually got a few different ways that that control signals can move amongst devices inside of a network. One of them that is very, very helpful in a lot of scenarios is what we could refer to as machine-to-machine control. So if I have two pieces of hardware and one device detects a certain condition, it's going to send a command over to another device to do something. For example, if there is a fault in a DSP, it's going to send a command to recall or bring in a standby device to act as a backup and take it over. Or maybe we're doing something with a contact closure. So a fire alarm is going to close a contact. That's going to communicate back to a core DSP in the system. That's then going to send a command off to an amplifier to recall an emergency evac preset, for example. Those are situations where the machines are actually talking to each other and the user doesn't necessarily have direct interaction with them. But of course, there's also user-to-machine interaction, where I, as the operator, am going to be interoperating with and adjusting parameters, turning things up, turning things down, recalling things, and making general live, real-time adjustments to the hardware and to the system. We could, of course, have scheduled and automated types of control, and we could have what I like to refer to as interactive versus persistent kinds of commands. And this, again, goes back to sort of the difference between me as an operator sitting behind a user interface and making real-time adjustments versus something that's just sort of always there on the network, like a heartbeat timer or a status check for a device to make sure that it's still actually there and is still operating properly. So, where does all of this lead and what exactly does this have to do with control standards? Well, this brings us to AES70. So what is it? Fundamentally, AES70 is an open public standard for device control. This is a technology that a group of manufacturers within the industry really spent a lot of time working on to try to address this problem of how to get a full solution for a media network. At the time, about 10 years ago, that all of this effort began and the technology began to be developed, there, of course, was a lot of attention being paid to moving the audio around and the transport solutions that were available in the industry. But not a lot of time and attention was being put towards the control side. So AES70 was really started as an effort to try to bring out a standardized way of interacting with and controlling devices in a way that could be accessible, usable, and available to anybody in the public as an open public standard, not as a proprietary technology. Specifically, AES70 defines the device model. So how do we describe a device? How do we enumerate all of the different elements and the objects that exist within that device in a way that makes it possible for us to actually interact with and control that device? Part of that, of course, is the object class tree. So once we decide how we're going to model the device and how we're going to describe it, we then need to actually come up with standard objects and ways of expressing these different parameters and these different objects that exist within a device. So this all goes into the object class tree as far as how we begin to define the parameters, the objects, and the handles so we can actually interact with them. The third component, of course, is a communication protocol. So how am I going to enable the communication of all of these different things on an actual network? How am I going to put this information actually onto the wire, get it into the devices, and get it back from them? As important as what AES70 defines, though, is what it does not define. So it specifically doesn't touch algorithms. When we were beginning to work on the standard itself, we were very careful to try to draw some fairly firm lines in the sand as far as what we were going to try to undertake and what we were not. And when we were looking at how you describe a device, it became apparent that you need to be able to enumerate and describe something like an EQ filter, but we don't want to describe how that filter has to actually work. So we sort of draw the line at saying this is how you're going to interact with a parameter for adjusting the level or the slope or the filter type, but we're not going to get in or intrude on how the math actually works or how the algorithm is actually designed inside of the system. Because philosophically, one of the reasons that we wanted to be able to bring AES70 to the market was to break down these walls that were limiting choice and forcing people to buy certain pieces of technology because they spoke a certain kind of control language. We really wanted to make this easier for people to specify and use the product that they felt was right for a given application in a given job. And a big part of that, of course, gets into how the devices work, what the algorithms are, how they sound, and how they actually work inside of the situation. So a good example of this is in the world of MIDI. I can have a keyboard controller, and I can hook that MIDI output into a Roland tone module and into a chord tone module, and I can press a key. That's going to send out a standardized MIDI note on command to both of those tone modules. They're going to respond to the grand piano patch, same command, same control, same function. But you're ultimately going to get out two completely different sounds because the samples are different and the samples are unique between those two different devices. So that's really a good metaphor for sort of how we define that line between describing and standardizing the objects, but not the algorithms. We want to leave devices unique and not homogenize everything. The second thing that we don't define is a user interface. We really leave this up to the designers to build up their graphic user interface or their human-machine interface in whatever way, shape, or form they wish. So there are no restrictions on how that interface gets built up. It could be coded in any number of languages. It could be a thin application, could be a thick application, could be a web application. The sky's really the limit with how this could be built up. So again, we only provide the mechanism to send out the commands and receive the commands to the devices. We don't describe how exactly that's done, and we don't mandate any specific method for building up the user interface. And lastly, we are transport agnostic. So AES70 can live alongside, interoperate with, and coexist on the same network as any kind of audio transport or no audio transport whatsoever. So whether you are using Dante, AES67, Ravenna, AVB Milan, or anything else that's available today, AES70 is able to peacefully coexist with any of those technologies and live happily alongside them in the same system. Now, many people may have also heard the term OCA. And what exactly is that, and how does it relate to AES70? Well, we began working on this technology that would become AES70 going back in as early as 2009. And as we worked through this technology, we built up this group of 11 different manufacturers from around the industry to come together to really, really beat up on the technology and try to define how it was going to work. We needed a name at the time when we began to do the development, so we chose the term Open Control Architecture, or OCA. And this has stuck with the technology, and OCA was eventually standardized by the AES as AES70. Now, because some manufacturers had actually begun to implement the technology in advance of the standard, the name was used in literature, it was used in the industry, and it stuck around. So the terms OCA and AES70 are, for all intents and purposes, pretty much interchangeable. Much the same way that MADI is the informal version or the informal name for AES10, OCA can be used somewhat interchangeably with AES70. The technology itself was developed by this group, the OCA Alliance. We were formed as a nonprofit trade association, and after the initial work was done on the standard itself, we of course handed this over to the AES to go through the formal process of standardization and ratification to be able to bring it out as a true open public standard. So today, the OCA Alliance, of course, still exists, but I think it's also important to talk about sort of what the motivation was when we began to look at this. At the time that we were putting this technology together, there were certainly a number of different control protocols that were being used around the industry. And one of the first tasks of the OCA Alliance was to sort of go out on an investigation and see if we were actually going to reinvent any wheels. So we began to look at every type of control protocol or technology that we could find. OSC, ACN, MIDI, KNX. There were a couple dozen different technologies that we looked at as we began to investigate this, including the good old AES24, for anybody who might still remember that. And what we found is, while all of those technologies were actually quite good and capable for what they were trying to do within their certain scope, they didn't quite cover the ground that the group needed it to. You see, we had a very broad constituency from across the industry in a number of different application areas. Some people needed very small, very compact, very lightweight control protocols, while others needed incredibly scalable technology that could go up to massive networks of tens of thousands of devices scattered across LANs or WANs and large geographic areas and very complex networks. We needed things that were going to have standardized objects. It needed to be flexible enough to be able to work with, scalable enough to be able to work within a framework and be able to be interoperable, but at the same time allow certain levels of customization. It had to be highly robust, something that could work in a very, very highly critical system. It had to be securable, so it needed to be able to support encryption. And while all of the technologies that we looked at were able to touch on some of those criteria, there was really nothing that was able to address all of them. So this was really the motivation to begin the work in developing AES70, or OCA, into what would become AES70. So the OCA Alliance still exists today. And we, of course, spend our time now doing a couple of different things. We work to continue to enhance and expand the AES70 standard. We feed things into the standard process, as well as recommend best practice elements and documentation that can go along and support and supplement the standard itself. We also spend a lot of time working on promoting the technology, trying to assist and support developers or the community as they're trying to work with or learn about the technology. And we provide a number of different resources for the industry. So software, tools, hardware reference designs, a number of other things that we make available for free to try to aid in the development of and the adoption of the AES70 standard into devices. So let's take a look at a couple of different examples as to where some of this can be used. Now, when we talk about this magical world of everything using a common control standard and using the same objects, a lot of times it's very easy to sort of go to the nth degree and imagine everything interconnected with everything else and talking to everything else, and it becomes this very complex and very convoluted system. But the reality of common control and how we tie things together in system designs a lot of times is actually a lot simpler than that. Usually we're just trying to achieve a handful of functions that are going to add a lot of value to how the user's workflow actually is impacted by the devices and how they interact with the systems. So here's a couple of different use cases where we can look at some of the interactions that a user needs to have as part of their workflow, and some of the traditional challenges that come up using other kinds of control and how AES70 has addressed those. So we'll start off with a fairly simple example using a mixing console and an intercom system where we have a third-party wall controller that's going to interact with them and a third-party graphic user interface existing on a computer. Now, what we need to achieve here is the transmission of control parameters from both the wall panel to the devices and also from the user interface to the devices. Where this gets a little more complicated, though, is we may be interacting with different parameters on the user interfaces, but we may have some overlap as well. So we need to look at situations where we're dealing with concurrent users and how they're interacting with the same parameters on the same devices at the same time. Some of the challenges that a system like this actually brings up are, number one, the obvious one. I've got multiple manufacturers, and anybody who's worked with some of the integration solutions that are out there today, Crestron, Extron, AMX, are familiar with the documentation and the challenges in trying to integrate some of these third-party devices from different manufacturers. The languages are different. The protocols are different. The way you need to design the interface and actually communicate with them are all different. So AES70 straight away is a great solution here because it's the same device model. It's the same standard. So if you really understand how the technology works for one device, it's exactly the same for all of the other devices, just with different parameters and different objects. Technically, we need to deal with persistent data. So we need to deal with things like VU meters and the HMI that's actually on a piece of hardware. When we're dealing with a scenario like this, it appears at first that you're only dealing with two different user interfaces. I've got my wall controller and I've got my external GUI on the PC. But we have more than that because we also have the interface that's actually on the hardware. So we've got a couple of very interesting challenges here in how we interact with this. Not only do we have to make sure that we are getting consistent data on all of the devices, and we've got a single source of truth, so everything is showing the same interface, but we also need to have an intelligent way of pulling in some of this information, like LED meters or VU meters. We don't want to use just a constant polling of that interface. We want to be able to manage this in a slightly more intelligent way to be able to deal with bandwidth. And we could do that using some of the mechanisms, the subscription mechanism specifically, that's contained within AES60 or AES70. We also have to deal with this concurrency of parameter adjustment. And what this means is if I've got two different interface points, it could be the wall controller and the graphic user interface on the PC, for example, and I get two users that are interacting with the same parameter on one of these pieces of hardware, how do we make sure that everything stays synchronized and every device that's connected to and exposing that parameter is actually showing the true state of the device? This is something that AES70 is able to achieve through a subscription and notification mechanism. And we'll talk about this a little bit more in detail later in the presentation, but this is a really, really important concept for being able to make sure that the device itself is always the single source of truth. So when I have concurrent users, or if I have an issue with one of the devices on the network where it perhaps becomes disconnected and then reconnects later on, we have a way to make sure that we're always getting the most current, most accurate state from any device and any parameter within that device. This encourages UI consistency because there's nothing worse than having two conflicting interfaces that are telling you two completely different states of an object or a device. So let's look at another example. Here we have a mixing console that is connected to a number of different amplifiers, all from different manufacturers, as well as a radio microphone, wireless mic. And for example, let's say that we have a user interface actually on the mixing console that's able to actually display the health status or some of the critical device information of those connected devices for the user. So what we're going to need to do is actually receive and transmit all of this information from the devices and be able to display those on the interface on the mixer. So some of the challenges that are going to come up with trying to design a system like this are first going to be the potential for different monitoring parameters. This is another place where control can become deceptively complicated. A really good example of this is something as simple as power state. So if I have an amplifier, how many power states could that amplifier potentially have? As we began to dig into the definition of that object itself, we realized that there's actually more than you might think. So, for example, manufacturer A may just have two states. Perhaps it's got a active mode, where it's passing audio full tilt, full rock and roll mode, and a standby mode, where it's not passing any audio. But amplifier B might have active and standby, but maybe it's also got something along the lines of a low power mode, where it's only going to pass audio once it reaches a certain threshold for sort of an instant on, something that you can find in public address systems, for example. There's a number of different states that could be existing just within power. So we need to have a way to be able to describe all of those different states for a unique device, but still do this in a standardized way. So this is a big advantage that AES70 has in being able to actually enumerate and describe all of those different parameters that exist within a device, but in a unique way. So they all have power, but if device A has 2 states, device B has 3 states, device C has 5 states, those can still be expressed using the same objects and the same tools within the standard itself. And this helps us build up a consolidated user interface. So we don't need to create a number of variants or a radically different way of presenting that information. This is something that can be very important when you're dealing with size-constrained screens. So I don't have a ton of real estate to be able to do a lot of customization or even necessarily show everything all the time. By being able to use these standardized objects, we can consolidate this and still provide for a consistent but consolidated user interface. Thirdly, we could be having different device capabilities. So we have our amplifiers that are capable of a number of different operations, have a number of different parameters, but then we've got our wireless microphone, which is going to show us a number of different things and have a variety of different parameters inside of them. All of the devices, for example, will have gain and be able to show a VU meter illustrating the gain. But maybe I also want to be able to look at things like RF signal or a number of other parameters that are existing within the wireless microphone. Again, we could still use these standardized objects to be able to tie those back in to the harmonized user interface inside of the GUI. Lastly, we've got, of course, the mix of different kinds of hardware. So the beauty of a standardized control interface is it allows us to use these common objects to be able to have a level of consistency, and we can express everything in a very consistent way. We could do our programming in a very consistent way, but we still have the ability to respect the uniqueness of the devices and what they're capable of doing. So it allows a designer to be able to really strike that balance between consistency and harmonization, but also differentiation and distinction when they're building up the interface and for the controls. So a third example that we can look at for a use case is a public address system, where we have a PA system and a paging station that is provided by one manufacturer, but we want to be able to connect to a different kind of amplifier from another manufacturer. So we may be doing our 70 or 100 volt systems locally within the public address system loop, but we still want to be able to connect to something that's got some high power output for a performance venue or something else where we need very high levels of output. So we need to be able to communicate a few different things across the network. When a paging event goes on, we of course want to be able to communicate that to devices, for example, to perhaps change the routing or maybe recall a intelligibility focused DSP preset inside of the system. If we have a status event that goes on inside of the system, we want to be able to send that out to the system as well. So an example could be if we have an emergency event that's detected or occurs within the public address system, we want to be able to send a remote command to the other devices, for example, to the professional sound amplifier, maybe to change its routing, maybe to recall a separate preset, or maybe just to mute altogether and allow the evac system to really take over and run the whole show while that's going on. And of course, we need to have the status indication of all of these different things going on at once presented to us inside of a user interface. So some of the challenges that come up in designing a system like this are, of course, figuring out how to do this machine-to-machine connection. And there's actually a very traditional, very old school way of doing this that is still in existence today, and that's just running a good old-fashioned pair of wires between a GPI and a GPO in systems to close off a relay. Happens every day. It's very quick, it's very functional, but you've got this network that's already there on the system. Let's just send that information directly over the network, particularly if we've got large geographic distances or very, very difficult runs to make with that wire otherwise. We've got the network. Let's try to take advantage of that. Again, we need to consolidate the user interface. So depending on the elements that are going to be left for configuration only that we may have inside of the public address system versus interoperation and real-time live adjustment that we may have inside of the public address system, we want to be able to design an interface that allows us to address both sides of that coin, expose what we need to, hide what we don't, and tie together those two different pieces of technology into a single UI for the user to interact with. Something that's popping up in some public address systems today is the use of encryption for security. So within their system loop, if you will, the devices are communicating and exchanging both control information and audio in a secure, encrypted way. That's something that may or may not be present on the side of the third-party amplifier. So we need to be able to have an interface that we'll use on our software or in an external controller that can interoperate with both secure and encrypted and insecure and unencrypted control channels simultaneously. AES70 happily supports encryption, so we're able to address that. We might also have a situation where we're dealing with a number of different kinds of audio feeds. So it could be a system that's using a combination of Dante, AES67, maybe analog audio, or a number of other things, depending on what exactly the systems use. And again, we could be dealing with a situation where we're dealing with encrypted audio on the public address side, and we need unencrypted audio on the professional sound side. AES70, again, is able to interact with any of these different types of protocols because it really is transport agnostic and can interoperate with any of them. So let's take a bit of a pivot now and dig into how exactly some of these fundamental building blocks of AES70 actually work, and look at some of the object classes that we can find and how these come together. So AES70, as it built up the device model and how exactly a physical device is actually described, begins to work with object-oriented class structures. This is a very orderly and easily understandable way of grouping objects together in a way that becomes more useful, more understandable, and more intuitive. So within AES70, the actual objects themselves are broken down into a number of different categories. So we have the four core workers, managers, agents, and networks. And these actually describe all of the different types of objects or functions that could be existing within an AES70 device. Drilling into workers a little bit more in detail, one of the things that we identified as we were looking at other control protocols is the way the objects were actually put together sometimes tended to skew to too generically or weakly typed in a way that broke down interoperability because you were never quite sure what you were going to get when it came across the wire, or the pendulum swung to the other direction and they were too strongly typed. And the standard itself became so rigid that if you had anything that was approaching something of an edge case or something that didn't perfectly fit into the box that was defined, it became really, really hard to use, or you had to hack your way around it. So when we began to build these things up, we really tried to keep in mind the flexibility of the devices and the designers and how we could support both the standardization and making sure that things could still talk to each other in a reasonable way, but also allowing flexibility. So people were able to do the right thing for the device that they were working with or defining. And that led us to allow what we refer to as a proprietary class. All that really means is within a device, I've got a number of different objects, and those objects can be described using these standard classes. So I can have a switch, for example. I could have a gain adjustment. I could have a VU. I could have a number of different things. And those different classes and different objects really align quite well with what you're going to find inside of a standard device. But the challenge comes in, again, if you're dealing with one of these edge cases that isn't quite something that fits into the box or the class that's already been defined. So AES70 actually allows a manufacturer to create a proprietary class, but to do so in a way that's discoverable, interactable, and controllable by other controllers or other devices, even if it's never seen that class before. So it will discover the device, it will enumerate that specific class, and then it becomes something that can be interacted with just like anything else. This really allows us to provide high levels of flexibility, but we still retain that standardization. So there's still a common way of doing things. There's still this common level of discovery. And even when using some of these proprietary elements, it's still very, very easy to adopt and build up a controller to actually interact with the system. Most importantly, as all of this comes together, a very key component of an AES70 object is a human-readable role name. And again, anybody who's built up some of the control systems that are out there and had to deal with the documentation from products that are trying to support it know how painful this can sometimes be to figure out what objects are actually doing what. AES70, of course, contains all of that good stuff like unique object numbers, class identifiers inside of the protocol, but it's always accompanied by a human readable role name that is discoverable along with the class itself. So it's very easy to find which switch specifically is the channel to mute on that device that you're trying to interact with. Looking at this in a bit of an example, we'll switch into a little bit of a computer science digression here. But as a designer, if I'm trying to actually build up a control object to implement inside of my device, I can use an example of inheritance. And the way this works is fundamentally everything inside of the class tree in AES70 exists within OCA root. Moving down one level from OCA root, OCA worker is derived. And OCA actuator is actually derived from OCA worker. And from OCA actuator, I can derive OCA switch. So I'm inheriting all of the functionality and all of the abilities of the class above me as I create and derive these new classes. And of course, this can continue on. So if you as a manufacturer have something that's really, really specific, you can continue to derive additional unique classes while still using the standardized class. This last image here is just an example of how this really winds up looking inside of a device. So the document itself is what we refer to as an AES70 implementation specification. And this is a resource that the OCA Alliance makes available to manufacturers to be able to document and expose all of the controllable AES70 objects that exist within a device. So if you look at this example here, this is specifically for a Focusrite RedNet 8. We can see that this contains a number of different objects, and specifically a number of different switches, as they're enumerated on the leftmost column of the image itself. If we move over to the rightmost column, though, we can also see where the human-readable role name is actually identifiable. So we can look at this and see how the manufacturer has actually chosen to use the objects, use the specific classes within the device itself, and how those have actually been exposed and implemented within the device for how this is going to fundamentally work. It's important to recognize, though, that AES70 itself can actually go well beyond audio. Yes, this is the Audio Engineering Society, and yes, the group that began to develop this was a bunch of audio manufacturers. But one of the philosophies that we always had when we were beginning to work on this is, how do we extend this out? If we look at broader integration systems, this actually goes well beyond audio. If I'm dealing with a performance venue, for example, I will have things like lighting. I will have intercom functionalities. Maybe I've got business functions inside of the building itself to work with a building management system. Maybe there is staging or automation or telemetry that goes on inside of the actual stage in the venue itself. AES70 was really designed in a way using this object orientation and using some of these design philosophies for how we built this up to be able to extend it well beyond just the domain of audio. So we can use this inheritance and this derivation and these different types of classes that we created inside of the system to create a number of different classes that could apply to really anything. And a really good example of this is even the standard classes are generally pretty universal. A switch is a switch is a switch. We are turning things on and we are turning things off. That is a standard object that could be really used by anything that has a state that need to be toggled. Likewise, things like gain controls or filters. Those are parameters that can be used in a number of different applications or a number of different domains without even having to change the name or the nomenclature. But if there is any need to create something that's truly outside of the object class tree, there is a number of different resources or a number of different objects within the standard itself that could also be used. And as we created these strongly typed objects, of course, we also created a number of weakly typed objects to really try to provide this flexibility for people to be able to do what they needed to do if it didn't necessarily fit inside of the box. These still contain the human readable role names, so we can still discover them, enumerate them, and figure out what object we're trying to actually interact with when we connect to that device and when we build up our controller. So a couple of examples of these. We've got some basic sensor types that exist within the class tree, and these contain things like Boolean sensors, int8s, floats, strings, and a number of other attributes. Likewise, we have a similar thing for actuators. So we have a Boolean actuator. If we just need to toggle things between a 0 and a 1, we can do that very flexibly and very easily using one of these types of devices. Likewise with strings and floats and ints and a number of other options that are out there. And one of the things that we're very interested in doing is really encouraging other applications for AES70. And as those are used, we want to be able to pull things in from how the industry is using the technology and be able to incorporate those into the standard and be able to expand this out so other people can take advantage of this as well. Now, I want to talk a little bit about networks and subscriptions. So how does this information move around on the network, and how do we actually send and receive updates from objects and devices? This is something that can really be an Achilles heel of control protocols when they're dealing with large, scalable, and highly complex systems. We have a number of things that we need to worry about. Some of them we've already talked about. So, for example, concurrency of interaction from users, data consistency, bandwidth preservation, synchronization, and just making sure that everything works the way it should all become really, really challenging as you add more and more devices and more control points to the network. So what we need to do is have a number of different ways that we can actually take this information, put it onto the network, and then allow the data to move around and how the fundamental mechanisms of data exchange work on the network. So to begin, there are 4 different types of networking protocols that are supported by AES70. TCP, of course, UDP, of course, WebSockets, and SSL via pre-shared key. So this allows us to actually encrypt and secure the control information as it exists on the network. And these can be mixed and matched. So for example, some manufacturers will use TCP for critical information that goes across a network, while using UDP for less critical information, maybe VU data that you can tolerate a drop packet here or there if you absolutely needed to. One of the other things that I think is also important to recognize about the different protocols is they are something that allow flexibility for different kinds of devices. So if I'm working with a very resource constrained piece of hardware, something that just doesn't have a lot of resources, a lot of RAM, and a lot of overhead, I may want to use something, I may want to use the UDP stack because it doesn't carry the obligation and the overhead of a complete TCP IP stack on top of it. So I can get an AES70 implementation down into something that's very, very compact and very lightweight. One of our members actually got a demonstration of an AES70 implementation down to, I think it was about 1 kilobyte on a demonstration that we did at ISE last year. And they were also able to get this up and running on a Raspberry Pi in something that was obviously a much more robust solution. But one of the examples that we provide as the OCA Alliance is actually a reference design that's pretty robust that can run on something like a Cortex M3 with about $30 worth of parts. So it's very scalable up or down. And that actually begins not just with the implementation, but also with the types of networks that we're able to support. But subscriptions are another fundamental concept that are really important to understand when we talk about how we're actually going to enable this communication and enable this interaction amongst these devices on the network. Fundamentally, a device or an object within a device specifically is always the single source of truth. So when I'm dealing with an integrated system, as I say, we've got a number of different potential points or control interfaces that I may need to know the status of that device. If I'm dealing with a piece of hardware, I've got the HMI that's on the front panel. So I've got the front panel display and the knobs. That's an interface that I need to be able to update. Then in addition, we add everything else. So maybe there's a wall panel controller. Maybe there's a software user interface. Maybe there's a third-party controller or touchscreen that's out there. We need to be able to make sure that if I send a command from one device, that everything else actually stays in sync and everything else actually reflects the true state of the hardware itself. So fundamentally, the device or the object is always the single source of truth for a status. Another thing that's really important about subscriptions is this can reduce bandwidth because we're not polling parameters constantly. The way a polling mechanism is typically going to work is you're just constantly querying a device or an object. Where are you now? Where are you now? What's your status? What's your status? What's your status? Those are constant messages that are going on to the system all the time, whether or not anything is actually happening. And that can become very, very inefficient. So the way a subscription works is a control object will subscribe to an object within a device, and it will only update its status once that object itself has actually updated itself. And as we've discussed, this is really important for multi-controller systems, and it reduces overhead. So the way this actually works is if I am a control interface and I am going to send a command to an object to ask it to change state or to update, I am going to send out a command to that object. The object itself is going to receive that command, and then it will acknowledge whether or not it was able to do it. But most importantly, it's then going to publish a notification out to any other control object that is actually subscribed to it. That is what's going to cause the update on those interfaces to actually happen. So this becomes a very, very scalable and very flexible type of mechanism where you only have these objects subscribing to each other when it's relevant and when it's actually needed. It becomes a very efficient way of managing bandwidth and ensuring that the information only gets to the devices that actually need it, while at the same time ensuring that everything is always up to date with the most accurate and true status of what the object itself is. This is also something that's very important when we are dealing with ad hoc or dynamic situations. So if I am connecting up a new controller, I need to be able to find out what the status of that object is as soon as I connect and go online. But if I disconnect a cable, or if something happens and that device drops offline and then comes back on, it needs to be able to get the real status of the object itself. All of this is achievable using the subscription and notification mechanism to make sure that everything always stays concurrent and stays synchronized. So let's shift gears and talk a little bit about audio transports. Now, one thing that I've mentioned a couple of times and I think is truly important about the AES70 technology is it really is transport agnostic. This will work alongside any combination of media networking transports, or of course no audio at all. If I'm just dealing with something like a simple control interface, there may or may not be an audio transport component to go alongside of that. Obviously, that's a completely valid use case for AES70, and it's happy to provide you a good control protocol for building up such a device. But if it is living alongside an audio transport, as we mentioned at the beginning, one of the flavors of control that is really important to think about in a media network is how I'm dealing with audio connections. How do I set up and establish and tear down and monitor all of these different audio paths between my sources and my sinks on my media network? For people who work with Dante, again, this is what Dante Controller is fundamentally doing. It identifies the devices. When you tick that box off between a transmitter and a receiver, it nails up that connection and allows audio to move back and forth. Well, with other technologies, we also want to be able to incorporate a standardized way of being able to deal with this. So AES70 is capable of adding a connection component through a document that goes along with the standard that's referred to as Connection Management 3 or CM3. So the current scope of the document is really focused on AES67. and it is a way that you can use AES70 to nail up and tear down these connections between native AES67 devices, which coincidentally makes AES70 a really, really strong counterpart with AES67 for building up a pure standards-based media networking solution. But other work is ongoing within the SC0212L group for defining additional elements that CM3 could be expanded to touch on. And this, of course, includes things like ST2110-30, which is based on AES67. There is work going into a definition for AVB and Milan. And there is discussion and work going on with some other protocols that we can't quite talk about yet, but the goal here is to allow it to talk to and work with and do connection management for a number of different audio transport protocols. Just a little bit of a look under the hood as far as what exactly is going on here. When we are nailing up and tearing down these connections, it's a fairly complex dance of not only being able to identify the streams that are coming in, but also mapping those streams and those channels to discrete channels within the device itself. We need to be able to enumerate and identify and then establish those connections in a dynamic and a quick way, not only on the input, but also on the output. So this is something that AES70 actually has all of the primitives and all of the hooks to be able to do. It can set up and build out these complete connection management maps inside of a device. The big question when we always talk about standards is, gosh, how do I know this stuff is actually going to work together? As wonderful as the standards world is, there's always a potential for somebody to be able to do something just a little bit different that breaks the standard. And device A doesn't necessarily speak to device B. So how have we, as the OCA Alliance, decided to try to address this? Well, there's a number of different things that you can do to try to ensure interoperability. One easy way to do it is to just buy absolutely everything from the same manufacturer. This is one great thing about buying Dante, for example. Everything is coming from Audinate, so you know that there is a extremely high likelihood that everything is just going to work together. Another way that you can ensure interoperability is to do a testing and certification program where a given manufacturer who's implemented a piece of technology is going to send their piece of hardware off to a lab where it's going to be tested against other pieces of hardware, automated tests, test routines, and a number of other things to make sure that things are actually done properly. And it connects not just to the device at the opposite end, but it's happy with everything in between. So it can also work with things like switches, network infrastructure, and everything else. A third sort of middle ground for how this could work are things like plugfests, where manufacturers get together and connect their devices to each other and do formal or informal testing to make sure that things are going to work. Sometimes those are accompanied by the publication of a interoperability and conformance document referred to as a PIX to actually show what and how things were implemented inside of a piece of hardware. And then there is another method that you can use where you are basically just providing implementers with the tools that they need to actually ensure that things are being done correctly. This is a big challenge. And when an organization is looking at what the right solution is to ensure interoperability, it's always important to sort of weigh the pros and cons of these different approaches. On the one hand, we certainly want to make sure that things work when they get into the field. We don't want anybody to have that nightmare experience of something not talking to something that it should be able to talk to. But at the same time, we also don't want to provide more overhead or more infrastructure than is necessary for a given interoperability test, because that can cost time, it can cost money, and that can actually drive up the cost of a product, or in some cases, it can lower adoption. So that option is usually best reserved for when it's really, really necessary and we're dealing with a very complex piece of technology that really, really benefits from going through that sort of rugged testing. So what we've done as the OCA Alliance is provide a couple of tools that are available to the industry to be able to build up and work on interoperability assurance. The first tool that we provide is something that we refer to as the OCA Compliancy Test Tool, or the OCTT. This is a utility that is free and available to anyone in the industry to download off of the OCA Alliance's website. And it is something that can be used to be run against a piece of hardware to actually validate the implementation. Make sure that the minimum required specifications, the minimum objects are being implemented, and that what has been implemented inside of the hardware has been implemented properly. So this is a utility that we provide for people to be able to run and ensure that, yes, everything is actually working correctly. And if it's not, it will give back a report saying, this is what failed, this is what needs to be fixed. The second thing that we provide is a document template that's referred to as the AES70 implementation chart. For people who are familiar with things like MIDI implementation charts, this is very much along the same lines. It is going to describe and enumerate all of the different objects that are existing within a device. It will provide the technical information with things like the class ID, the version, the object number, and the role name. So anybody who's looking at one of these documents can actually see what's inside of a device, what's it called, what are the version numbers, what are the object numbers, and actually see the capabilities of the device itself. Between these two components, we really feel that this strikes the right balance between assurance to the industry that things will work together through validation with a test tool, and also ensuring that person, a user, an integrator who's going to pick up a piece of hardware is going to have a high reliability, that it will actually be able to interoperate with something else because they can see what it's actually capable of and how the device itself physically works. Speaking of devices and how they physically work, is this real? Is AES70 actually something that is being used, is on the market, or is it just sort of a piece of vaporware that we've been hearing about on and on and on since the standard was released in 2015? Well, I'm very happy to say that yes, it is in fact a real thing. There are shipping products from 13 manufacturers, a total of 72 shipping products today. More on the way that are available and for purchase right now. There's a number of others that are going to be coming out that manufacturers will be announcing in their own time. And one of the things that the OCA Alliance has really been focused on doing is trying to make this connection between not just the technology, but also the manufacturers and the general public for people who actually want to try to find these things. So a brand new resource is actually about to be launched from the OCA Alliance. We've just recently done a complete new website and have relaunched that, but there will also be a brand new product page that will be available on the site. Now, we've published a page that contains all of the different available products that are shipping today in the past, but this new page is actually going to take that to the next level. We've added a number of additional tools for people to be able to search and filter and find different categories of devices with different attributes, so you can really drill through and find the specific kinds of products and the specific features and functions that you're looking for in a much, much faster and much more flexible way. This site should be live in the next couple of weeks. We're just dusting off a couple of final touches on some of the technical side of things. And then once that's available, it will be live for everybody to see at the OCAalliance.com website. A question that comes up all the time, justifiably so, is what kind of third-party controllers are actually taking advantage of AES70 at this point? And the honest answer is there's not as many as we'd like. We are seeing more coming out. And as we're seeing more and more products become released with AES70, we're expecting this number to grow as well. AES70 and control standards in general tend to take a little bit more time to get implemented into products than perhaps audio transports for a couple of different reasons. Control itself is something that gets a lot deeper into the device. It touches a lot of different things. And as we discussed at the beginning of this presentation, control itself is actually a very, very complex process and touches a number of different things. There's also an issue, of course, with design cycles and legacy. So as a manufacturer, how do I make the transition between using this protocol that I may already have in my products and incorporating something in addition to or as an alternative to what I've already been using? So the good news is the adoption curve of AES70 has actually been very consistent and is increasing as we go through time. And as more of these products are coming into the market, we're seeing more and more third-party controllers begin to come up. So some are available through scripting. For example, QSC and PV have supported AES70 products using scripting with some of their systems that are out there. Beckhoff Automation supports AES70 completely inside of their TwinCat 3 package. This is a commercial package that's available through Beckhoff and can be implemented in their control and automation platforms. They, of course, include touch screens and a number of other systems as well. So this actually includes native AES70 support. And Doiso, one of the OCA Alliance members, offers some libraries and some resources for creating third-party controllers as well. They provide a JavaScript library that's actually available for free for anybody who would like to use it, but they provide commercial libraries as well in a number of different languages for people who would wish to develop those. There are some additional third-party controllers that are in development at the time, but we can't talk about those just yet. This is really one of the things that's going to become a fundamental part of how we interact with these devices in the future. We need to be able to have our configuration and our control. We've got the protocol that's in place. We've got the products that are supporting it. And now we're beginning to see the third-party controllers become available as well. So this is really an ecosystem that's just going to continue to grow and expand over time, really for the good of the industry itself. Some resources that are available for the industry. The OCA Alliance has a website, ocaalliance.com, where we host a number of different things that are available for people to review, look at, or actually work with in their development and their implementation. So on the website, you can find a number of different presentations and white papers on AES70. We have a number of additional technical resources for developers and integrators alike. Some of these include the compliancy test tool that I spoke about earlier, which again is a utility for validating AES70 implementations. We have something called an OCA micro demo. This is a hardware and software reference design that was initially put together to show off a couple of things. First off, provide some resources and a playground for people to be able to use the technology and see how it actually worked. But it's something that is complete enough that you could actually build a product out of it. It's designed to be very compact and very lightweight, very inexpensive as far as the hardware BOM that would go into building something up. We provide the reference design as well as all of the software resources available up on the OCA Alliance website. Our friends at Focusrite provide a virtual RedNet device, which is a utility that can be run on a desktop or a laptop, of course, for testing or evaluation. There are actually some fairly clever things that you can also do with the code if you're looking to develop a proxy to be able to translate or implement AES70 directly into an existing device. There is the AES70.js JavaScript library, which can be used for building up user interfaces for the web or for Node.js. There is a Wireshark plugin that can be used for evaluating and analyzing network traffic on an AES70 network, and all of these resources are available for free and to the public. And this isn't the end. The mission of the OCA Alliance is really to support the development community, support the AES70 ecosystem, and try to bring these products to the market and support people who want to implement it. Our mission is really to try to expand the world of open control. We want to make this easier to use because it not only makes our lives as manufacturers easy when we get into integration scenarios, but it really knocks down the barriers to the types of integrations and use cases that designers, integrators, and users really, really want. Much in the same way that MIDI sort of democratized, harmonized a lot of the music world back in the 80s, this is really where we are hoping to be able to see the Pro AV industry go. So with that, I invite you to take a look at some of the resources that are available, explore some of the products that are available, and if there are any questions, now we'll switch over to the live feed where I believe people can ask me as they go. For those who wish to leave, thank you very much for your time. I hope you enjoy the rest of the AES presentations, and I hope the rest of 2020 finds you safe, happy, and healthy. Thank you very much.
Good morning, AES 149. Happy Friday. Yes. Brian B.T. Gibbs, I am the section chair in the San Francisco section for AES and coming to you from the Bay Area, actually in San Jose, South Bay. And Ethan, who's in New York, is coming to you live, but much more closer to everybody else's time zone. So good morning, Ethan. Oh, you're muted.
Good morning, and I'm actually in Minneapolis. So when I recorded the video, we were getting our first snow of the year. We've had 8 inches of snow so far, and today it's going to be sunny and 50 degrees. So, yeah.
I wish I had known that, because then we could have talked Juicy Lucy and Frozen Pudding, but we'll table that for now. Yes.
Absolutely.
So coming back to AES70 and standards and talking about the networking, we were having a lot of conversation around live sound and how, well, we were also talking horror stories, which are always fun, but just applying this to what was in the content to that live setting. Anything you want to add to what you know was already discussed in the presentation?
Yeah, I mean, I think in the presentation, we talked a bit about some of the different control scenarios and, how control actually works inside of a production, or when we're actually trying to talk to systems. But speaking for myself, kind of going back through my background and my history, I come from a place of doing production and being a performer, being a technician, being an engineer, trying to put all of these things together. And, I'm a MIDI geek going way, way, way back. So it's sort of second nature for me to try to get Gizmo A to talk to Gizmo B to do something cool, or to just free up my hands so I can be working on something else. And I remember with the live rig that I used to take out when I was still performing regularly back in the late 90s and early 2000s, I personally would show up with more gear than the rest of the band combined, right? So I've got 2 or 3 keyboards, I've got my samplers and my drum machines and my electronic drums and all of these other bits and pieces. And what I had to do was have this kludge of a laptop running old Cakewalk Pro audio sessions to push out sysx cues, to recall all of my patches on my pedals and everything else. And it was a nightmare, but I was able to do things that I was never really able to do before, because I was able to consolidate all of this control. And when we sort of look around where the industry is going today, with not just live production for sort of more traditional bands, but if we get into things like what's going on in the EDM scene and the electronic music scene, some of the things that people like Deadmau5 are doing with their productions, they're not just interacting with the music and their instruments. He's tied into his staging, his lighting, his video, and everything else. And all of that comes back to a tactile control surface that the artists can actually interact with. So I think this is really going to be where the future of performance goes. not just the artist sort of locked into their instrument, but really being able to interact with everything on the stage in a way that allows them to be more expressive and more performant in how they bring things out. So to sort of tie all of that back into the world of AES70, this is really a key motivation for me in trying to look at why control standards are really important, because it opens up those gateways to being able to do those evolutionary and really innovative things by tying different bits and pieces together and centralizing that control for the performer.
You were making me twitch a little bit talking about Systex commands and stage rigs with MIDI. And my friend, MIDI Panic, that was always my friend.
MIDI Panic!
Yes.
Absolutely.
Because I also attempted some of the things you're talking about. How far we have come. But you bring up an interesting point with the electronic music world, because that's also being chased in studio production, right? How can we get it out of the creative head into the creative brain, right into some sort of tactical? So you got all these different surfaces where I can just touch without really thinking, from either the machine to Rolly to all of these different things, where it's just, how can I be as fluid as possible from creative to output? But on the engineering side, it's the same thing, right? How can I automate as much as possible? So if I have a creative decision that I want to make, it as in sound reinforcement or whatever I might be doing in the whole flow of it, that ability to, as you say, automate commands is super helpful.
Well, and it's sort of interesting looking at it from both a performance perspective and an engineering perspective, because you're right, they're two very, very different mindsets. So when I'm working as a performer, what I want to be able to do is sort of manage the resources that I have. I've only got so many fingers and so many hands, and I want to be able to add potentially additional levels of expression to what I'm working with. So this is something that I do with my modular synths, right? You plug in modulation sources and LFOs, because that can act as sort of a virtual hand for you. I don't have to be twiddling that knob. I can assign that to something and let that do it for me. But working with something like a Rolly, if I'm playing with my C-board, I've got my depth and I've got my expression, I've got everything else. And all of that's musical. That's really, really cool. But what if I could also change the color of the lighting with my aftertouch command? What if I can add that as a gesture, to bring up a different gobo as I'm working through different interactions on top of my surface? That brings out this whole additional artistic level that you really haven't been able to do before without insane complexity and middleware. From an engineering perspective, one of the other things that we also need to worry about is, how do I capture that? How do I recreate that? When an artist is actually going through and dynamically working with all of these different parameters, what am I going to do to actually map this into the appliances that are either on the stage or in the studio? How do I bind that together so I can give that type of control to a performer? And if I'm going to try to track all of this stuff out, how am I going to record it? How am I going to capture it? How am I going to make sure that everything's actually working correctly? When you're stuck in this sort of sea of different technologies and different parameters, not only does that job become grossly complicated because of all of the mapping and translation and gateways that you have to put together for all of that, just to get the different languages to work, but it becomes very error prone as well. Because I need to rely on everything to be doing its job in that overall control chain. So this is the other big advantage that you wind up getting when you can start to look for a standardized solution. I can eliminate points of complexity and I can eliminate points of failure. So I can get on with my job as an engineer and focus on the line check and dialing in the sound and, maybe even grab a bite to eat in that 5 minutes before the lights go down.
No.
It does happen sometimes.
That can happen. I've seen that either in I was thinking secular and worship music, but in big concerts that I've been front of house for or monitor engineer. But I've also been called to help with big worship houses of worship, and what you say is what they're chasing a lot. This is completely applicable to that world because they're trying to use Ableton to trigger MIDI commands to come back to the stage, like you said, all that middleware to try to get the lights to do this and that. So what they're trying to convey with whatever the message is of the song, right? And that's agnostic. That doesn't matter if it's worship music or if it's secular.
Exactly. Yeah.
They want to create this event. So as an engineer, that's a great point. As an engineer, how do you provide that environment for them? That's a perfect way to put it.
Well, and I think one other thing that sometimes gets kind of lost in these discussions is, all of the things that we're talking about here. This is great and really, really cool stuff that, top tier productions are doing. And when you've got a dedicated engineer staff to put it together, sure, you can throw all the time and the money and the resources at it that you want. But what about the smaller, less technical, less experienced venues? How are we able to bring some of these really innovative and novel performance and expression technologies down to something that is accessible and easy to use for people who don't have as many resources or aren't as focused on this as their primary task, or maybe just dealing with volunteer staff that need to change every couple of weeks? So it doesn't have to be these completely over the top, next generation productions. It could be something as simple as, how do I harmonize controls so the volunteer sound person at that school can hit a button and bring down the lights, open the stage, bring up the mic, and start the show without having to chase down 8 million different interfaces and buttons. It really is about simplifying the experience.
That's an excellent point, and I do want to remind everybody we are live. We flipped out of the pre-taped, and there's a question coming in from Charles. I'll ask in a second. But the ability, so you've got the artist has a vision, right? Maybe the venue has a vision. And then they've got volunteers, and it could be a school. That's a perfect example. It could be a house of worship. It could be just a small club. But now you're giving the ability for all of these places to get it down to a volunteer who. And sometimes people just don't want to know. They just want to hit button and go. Right? iPhone has one button on it. It's just I want to hit a button.
And frankly, sometimes they shouldn't know. There's something to be said about reducing complexity. When I design a user interface, one of the biggest things that I ask myself is, how many opportunities am I giving the user to get it wrong and make the wrong choice? So by simplifying and reducing complexity, it just becomes a much better experience for the audience and certainly for the engineer.
So there are two questions, and oh my gosh, we're already getting down to time. So Charles wants to know about compatibility with existing network control standards, OSC or PJ Link. You got to.
Yep. So one of the things that we looked at when we were beginning to work on the standard itself was, sort of what were some of the problem statements that we and the initial team of people defining the technology had that weren't addressed by some of the existing technologies. So there is not direct compatibility or native interoperability with existing standards, or technologies, I should say. But one of the things that we have focused on is trying to make it very easy to build gateways and adapters and proxy translations between additional or existing pieces of technology and stuff that
so
might
they can
work
talk.
with that. Yeah. Right. And for example, this is something that Focusrite did in the RedNet boxes. They have a small proxy running inside of their hardware that's able to translate between their legacy protocol and AES70.
Perfect. And if we can answer this one in 45 seconds from John. So OCA Alliance, Trade Association, traditional manufacturer participating. Thoughts on how open source hardware, software world, Eurorack, Daisy, Bella, can take advantage of OCA, AES70, AES67. Seems they're not in the AL IP at all.
We absolutely love that, want that, and encourage it. So on the OCA Alliance website, there is a download section that will take you to our GitHub page. That's where we have open source technologies for both hardware, software, UI, and everything else. All free, all available. We want you to grab it, use it, and take this to crazy places that we haven't imagined yet.
Right. Greater in numbers, right? Many hands make light work.
Exactly. Exactly.
Ethan, you've been great. Thank you for participating in AES 149 and in the live Q&A this morning. So we will say to everybody, stick around for the next session, and thank you.
Thanks for joining, everybody. Have a great day.